Alright, so we're going to look at a third method of graphing lines, and that is using the slope-intercept form. So the first way, if you might remember, was pointwise graphing, making a chart of x and y pairs that satisfied the equation. The second way was to use the x and y intercepts. And now we're going to use a special form of writing the equation that's going to make it easier for us to graph the line. This slope-intercept form looks like y equals mx plus b, where m and b are numbers, and the letters x and y are just the letters x and y. So, m, that number, is our slope. And remember from the last video we talked about slope was the rate that y changes with respect to how fast x is changing. So that's going to describe to us what direction our line is going. And the y-intercept is 0, b. If you remember back when we talked about intercepts, to find the y-intercept you make x equals 0. Well, if you made x equals 0 in this equation, 0 times m, whatever that is, would be 0, and then b plus 0 would be b. So 0b is where the y-intercept is. This is going to describe how we can graph a line. It's going to give us a place to begin. That's going to be our y-intercept, and then it's going to tell us how to move to another point using the slope. The slope describes how fast the y's change with respect to x. So if you know where you're beginning at, you can use that to determine where a second point is. Some things about the slope that we should be aware of. If the slope is 2/3, what that's telling you is that you're going to go up 2 and right 3 from any other point you know to get to a second point. If instead your slope is -4, then that's the same as -4/1, and you're going to go 4 down from a point you know and 1 to the right. Notice in both cases I suggest we go to the right, and then it's just a question of whether we go up and down. If you start trying to go left, then it gets a little bit, you got to change your signs and stuff around. So I suggest always go to the right, and then if it's a positive slope, you go up, and if it's a negative slope, you go down. So let's look at a few problems. So let's say I want to graph y equals 1/2 x minus 3, y equals 3x plus 1, y equals -2/3 x plus 4, and y equals -2x minus 1. So what I'm going to do is first I'm going to begin each of these, and then I'm going to move to a second point for each of them. So this first, y equals 1/2 x minus 3. The y-intercept is -3. That's the b of my expression. So I'm going to put a dot at -3, 0, -3. And that's where I'm going to begin my graph. For y equals 3x plus 1 is my b, so I'm going to put a dot at 0, 1. Y equals -2/3 x plus 4. Positive 4 is my b, so I'm going to put a dot at 0, 4. And y equals -2x minus 1. -1 is my b, so I'm going to put a dot at 0, -1. Remember, you only need 2 points to graph a line. So the fact that on each of these graphs I've already plotted 1 point, I'm already half done with the problem. And I haven't done any work yet. Now I'm going to use the slope, the m, to describe how to move from the dot I've already plotted to a second dot. So in this first graph, y equals 1/2 x minus 3, my slope is 1/2. What that's telling me is from the dot I've already plotted at -3, I'm going to go up 1 and 2 to the right. And if I wanted more dots, I could continue that. From this new dot I could go up 1 and 2 to the right, and up 1, 2 to the right, and up 1, 2 to the right. And if I wanted to backtrack, I've been going up 1 and 2 to the right, well, down 1, 2 to the left, down 1, 2 to the left, that could extend the line the other direction. And I draw my line, but I don't have to plot a lot of dots, you just need 2 dots. So y equals 3x plus 1. Remember, 3 is the same as 3/1, so from the dot I've already plotted at +1 on the y-axis, I'm going to move 3 units up and 1 to the right. Remember, the top numbers, how far up or down you go, bottom numbers, how far to the right you go. And now that I have 2 dots, draw my line. So y equals -2/3 x plus 4. When you have a negative, we oftentimes want to think of that negative for a fraction as being on the top. by thinking of it that way, then we can have the bottom be a positive, which means we still go to the right. So beginning at positive 4 on the y-axis, I'm going to go down 2 and 3 to the right. And that's going to give me a second dot, and I'm going to draw my line. And then this last one, again, negative 2 is the same as negative 2 over 1. So from my dot at negative 1 on the y-axis, I'm going to go down 2 units and 1 unit to the right. And that gives me a second dot. And that's all it is to it. That's the basic way of graphing lines using the slope-intercept. I'm going to look at a few more special type of lines, but this is the general idea. And you should be able to graph lines even faster than I did here once you know how to use the slope-intercept form. Alright, so let's look at some kind of unusual lines. Y equals 2x, y equals 5 halves, and 3x minus 4y equals 16. So I'm going to graph each of these. Y equals 2x. Well, notice I want it to be y equals mx plus b. What's my b value? Well, if I don't have anything, my b value must be 0. And again, I can write 2 as 2 over 1. So I'm going to begin at 0, 0, or the origin. And then from that dot, I'm going to move up 2 and 1 to the right. And that'll give me a second dot, and I can draw my line. So if you don't see a constant value, that must mean the constant value is 0, and you're going to begin at the origin. So let's look at y equals 5 halves. Pretty much the same thing, right? Well, not so much. Notice that 5 halves does not have an x. That is not the slope. Just because it's a fraction, not all fractions are slopes. Some fractions are just numbers. And in this case, that's what it is. It's just a constant value. So I'm going to turn it to a decimal. My m is actually 0. That's why you don't see the x term. So this is actually 0x plus 5 halves, or 2.5. So if I want to write 0 as a fraction, 0 over 1. Just like I would do any whole number. And so I'm going to put a dot at 5 halves, or 2.5, which is 5 halves. And then from that dot, I'm going to go up 0, so don't go up. I'm going to go 1 to the right. And what am I getting? Well, this is a horizontal line, which, again, we talked about before in an earlier video. Y equals a number is always a horizontal line. So this is not really surprising. Let's look at 3x minus 4y equals 16. The problem here is this is not in the slope-intercept form. To be in the slope-intercept form, I have to have y by itself and everybody else on the other side of the equation. So that's the first goal, is to subtract 3x from both sides of the equation. Again, the 16 and the 3x don't combine. 16 does not have an x, they're not like terms. And then I'm going to divide everybody by the coefficient of y, divide everybody by negative 4. Negative 4 divided by negative 4 is a positive 1. Negative 4 divided by negative 3 divided by negative 4 is a positive 3/4. And positive 16 divided by negative 4 is a negative 4. Now I have it in that y equals mx plus b format. And so I know I'm going to begin at the negative 4, my constant value, on the y-axis. And then from there, I'm going to move using the slope of 3/4. I'm going to move from that dot up 3 and 4 units to the right to get a second dot, and then I can draw my line. So that's graphing things using the slope-intercept form. Most people use the slope-intercept form to graph their lines.